Oh, you're using your videos. So. Actually, I think it doesn't matter. Let's just start. No, don't worry. Well, here, I'll just mute you. I'll mute you. Mute myself. No, I don't need a microphone. Don't worry. Hi, everybody. Welcome to the Los Angeles Java Users Group. This is the August 2014 edition of LAJUG. Tonight's meeting is going to be on a topic called, how's it pronounced, Baratine? By Caucho. They brought us lessons, the execution server, which is really complicated. I guess it's still as usual, we'll start off with our usual announcements. So, are there any announcements to be made in the meeting?
Sure. So the topic we're starting a new book about things. So we're supposed to start it this month, but the big version is coming out this month. About race. It's
okay, and is anybody looking for work right now? Just one person. Would you like to talk about yourself really quickly so that anybody's here they can see if you can match?
Basically, I'm a Java technology, and my background is more like scalability, this kind of code from class. That's it. Experience with databases.
Okay. Anybody who has jobs that they can provide, so maybe. Okay, so one person does. Okay, so LAJUG in person has been shrinking, noticed, and I'm trying to move that online. And I guess getting parking here, did you guys find it really hard to get parking spot right? Okay, and then the next question is, how would you guys feel if I move this to downtown Los Angeles? Because I have a location that I could possibly meet there, but the parking is not as. I mean, I personally feel like this is endless. So we only have this few people showing up. I would like to expand this rather than make it smaller. South Bay LAJUG meets. I mean, South Bay Users Group is less than 4 miles from here. And there's a Santa Monica job, which is not too far from the either, actually. I don't know if I'm going to move to LA yet, but I really want there to be a bigger live audience than what we have. I don't know if that'll change things. It might actually make it worse than but no, I haven't. At least I'm putting the attention to the career first. And they have to become capacity. It isn't good. They know it's good business. They're not blind. But yeah, maybe we could get them in people from Burbank as well. So I'm going to consider that a possibility because it's kind of embarrassing to invite guests over. We have such a small turnout when before we used to have 20 something. Granted, back then there was only one LAJUG. There was not 5 or 12 anymore. Now with, I'm glad Meetup is out there. There's probably 2 or 3 tech meetups every day now this summer. I don't know which ones are big or not, but I want a bigger audience for this. We deserve it. Otherwise, I don't really see the point in continuing this. Even though it benefits me to learn which one. It doesn't benefit the presenters, I think. So, anyways, we're going to continue with the presentation. It will be online for those who decide to join us. And if it goes well, I might even make a YouTube out of it or something. So let's hand it off to you guys. Unmute yourself. And this is you, right? Oops. Okay, and then go to your presentation.
See it?
Yeah, I can see it. I'm gonna go outside and test if it works. No, because it's.
I know.
Go ahead and start.
Okay, great. Well, thanks for the introduction. My name is Sean, and I'm with Caucho Technology. We have with us Alex over there as well, and Nam and I will be co-presenting today. And we're here to talk to you guys about microservices. So talk to you guys about what they are, why they're important, why they're useful, and in particular, our personal solution is Baratine. Baratine is a microservice architecture. We're going to talk to you a little bit about why Baratine, is really fit for the microservice world, why it matters to you guys, and how you guys can start benefiting from its architecture, really starting today. So just as a sort of start off, to show of hands, how many people have actually heard of the term microservices since before reading the title here? So we got just one guy. Okay. Okay. So you're a little bit ahead of the curve. So microservices with Baratine. What are we talking about here? So looking at the Java world, looking at the programming world in general, there's always been this idea of business logic represented in data representation when it comes to making a service. So always that you coded your set of core attributes in terms of what it's going to do in one mechanism, and then the actual data that you were manipulating would be in another place, usually a database, MySQL, Postgres database, that your business logic would interact with, right? So there was always this idea of business logic and data, and you have your business logic that manipulates that data. And hopefully that's a good sign that we're on the world there. So when it comes to this model of business logic and data, which has been the model that has been prevalent since really the beginning of web applications in general, we reach now the idea of a React manifesto. React manifesto is a phrase that's been coined and termed to describe the demand of today's new age applications. That the new applications being developed today need to be agile, they need to be reactive, they need to be able to respond to demand, they need to be scalable, they need to be resilient, they need to inherently be all of these things on their initial release so that you can actually get the feedback needed. There's a lot going on with big data and analytics around the services that you're developing. But in terms of what the Reactive Manifesto means and what the Reactive Manifesto demands, taking a look at business logic and data, it's not a one-to-one ratio in terms of a complete handshake and agreement of what Reactor Manifesto is and what the current model is. So taking a look more at the traditional model, as I said earlier, architecture has really been represented as business logic and data. And what has this led us to, or what has this surmounted to in terms of your actual implementations? It's mean that we've had a set of execution that ran separately from the data that was actually stored. It's led to really the database being the bottleneck of most people's application, because you can have this code, the code can stream through as fast as possible, but when it comes to actually making manipulations, getting things done on the data, the database always is going to have to be synchronized. It's always going to have to be in sync and concurrent. And there's been a lot of ways to people try to mitigate this, but it's really been the bottleneck in terms of their application has been the actual database. It's meant that when you develop an architecture, usually deployed as a war file, traditional war file people are familiar with, it's meant that you're going to scale your architecture by duplicating that actual file. You know, it means it's hard to deploy specific changes when you have a lot of outside dependencies on your core code. It also means that people have in the past been afraid of really changing their application architecture because it's not innovation that's driving them, but rather the fear of changing something that's going to mess up their system. So if the system's running, let's not touch it. Let's just keep it running as it is and move on to the next thing. And it's also led to a really long-term commitment to a technology stack. When SOA principles first came about, service-oriented architecture was really talked about an implementation of WSDL and WSTAR, and not really, what it really meant was a lot of heavy XML syntax, a lot of extra code writing, bean interfaces, home interfaces, things that weren't really needed, or things that were needed just to get the core programs of your application that we're running today. So the traditional model, in terms of representation, we've had, you know, on the front end you have your client side, so that could be any laptop, any computer, smartphones, you know, are really driving the internet usage today and application usage. In terms of technologies represented in the application server side, a lot of JSP pages and servlets, Java Bean components were the traditional model of how you code an application in terms of representing that business logic and data, and then of course the data itself in a separate system, a database over here. A couple more negatives that it has led to is really developer productivity has been slowed down by this. Long load times, you have transitive dependencies, so if you have a current version of your code, current version of your application that's dependent on the outside source, and it's all packaged together in one WAR file, updating that one application means updating every single dependency that you actually have. It's really slowed the coordination down. And in order to get something rolled out, in order to get a sort of, you know, integrated source rolled out, a new version of your application requires a lot of actual development among the teams there, coordination. So when we take a look back at the Reactor Manifesto and some of the things that it actually demands. So as I stated earlier, it's demanding that, you know, applications today are rich and interactive, that there's a multi-device user experience. They need to be highly scalable because a successful application is one that's going to scale to thousands, if not millions, of end users. So they need to create and respond to production. And the idea that rather than maintaining your archaic stack, you're going to just be building services up and down and quickly ripping them down. So rather than build and maintain and live along for the future, what you do is you build a small microservice. It gets the job done. If ever you need to go back and modify a portion of your application, that portion now is contained within a bounded context of a microservice and very easy for you to update your application. So looking at the idea of the business logic and the data, the older model that we've had, the prevailing model, and the Reactive Manifesto, again, they're more clashing, that they're not complementary of each other. So if you take a little bit closer look at the business logic and the data, actually even closer than that, we can see that what we really need is a new model. What we really need is a new model that's not, you know, related. It's not specific around the older technology. So the older APIs that people have used, JCAS, JSP, JSF, EJB, models that were designed about 15 years ago, still in existence today. Models that were designed not for the multi-core nature of CPUs that are used today, and don't really take advantage of those. So what we would really need is a microservice model that incorporates both aspects of the Reactive Manifesto as well as takes a lot of, we are always going to be dealing with legacy code, the data and business logic model, and molds them into one. And it's with that that we present to you Baratine. So what is Baratine in essence? Baratine is a way to build high-performing resource services. So the number one thing that differentiates Baratine when it comes to the traditional model is the idea that you have a service and you have your data, and that we have single ownership of that data. So each service is responsible for maintaining and keeping its own service. Within Baratine, Baratine's a model that's built all in memory. People are taking advantage of the actual speed increments that you get when you move your operations into memory. So Baratine is a model that moves all of that into memory for you and gives you a sort of single owner, single write-up microservice architecture where the data and the business logic is truly an object-oriented fashion. You're writing services that manipulate a set of data, and they own that data. It's no longer are you going to a back-end database where all of your services have to be coordinated to, but rather your data for that service is contained within that. And then one additional factor of it is that it is in memory, so it's inherently going to be faster than anything going to disk. Databases are usually in disk. We do have NoSQL databases now, but again, NoSQL databases split the data from the service. Baratine combines the data that's going to be manipulated by that actual service. And rather than just sort of talking about the components of it, really just to show the simplicity in terms of what Baratine provides and what Baratine does do for you, we do have a quick start, and we're going to just jump into that right now.
Can I have a couple of questions?
Yeah, sure thing. Feel free to ask questions anytime.
Okay. So basically, the data resides in memory, so probably you have some replication of this data so that in case of a crash, you don't lose your data.
Yes, that's correct.
So basically, you kind of have the same K factor that other systems have. You kind of define a K factor that says, okay, this data lives into different locations.
Yes.
How do you manage the availability of this data to protect the crash?
Right. So we will actually get into the specifics of how we shard the data, how we replicate the data, how we recover the data. We actually have some slides for that later. So, but that is all relevant, and we will get to that. If we don't answer that question later on, feel free to bring it back up.
Okay, I'm sorry, I missed the beginning. Do you have a free download that you can take it out for a spin?
That's correct. We didn't actually mention that. That was actually saved for the end there. But Baratine is open source. It's GPL, so there's free download that you can start using today. And Nam's actually going to give us a quick walkthrough of that.
Well, thanks, Sean, for the great introduction. My name is Nguyen, and I'm one of the core developers on Baratine. And I'm going to show you what it's like to use Baratine in practice, what it's like to program in Baratine. And I'll demonstrate the simplicity of Baratine. So the core of Baratine is this single-threaded, single-owner model. It's one thread per service, and the service owns its own data. So this one thread per service sounds very familiar to you because Node.js is single-threaded, Vertex is single-threaded. So there are architectures out there that are also single-threaded. And why do they do that? Because it's faster. I'll go into the details later. But Baratine is unique unique from those other architectures because the service owns its own data. The data lives within the service. It's not in the database. The database doesn't know anything about the data. The service there is in the place where it's being used, which is in your service code. So these two important bullet points are very important. Keep that in mind as we go through the code examples and the presentation. So how is it like to program in Baratine? So let's find out. Let's download Baratine. So our website is baratine.io. And go to download. Baratine is GPL, v3. So we don't have to wait for the download because I did it beforehand. So let's cancel this. So let's unzip the archive. And this is Baratine. So how big was the download? Let's check that. Only 7.6 megabytes. Baratine is very compact, but it gives you a lot. I'll talk about that in more details. So let's start with Baratine. We do that by calling bin Baratine start. Everything is done on the command line. So there you go. We have Baratine running, but we haven't deployed any services to Baratine, so it's not doing anything useful right now. So let's create our very first Baratine microservice.
So there's not even a config file for it?
There's a config file, but everything's is defaulted for you. The default is install. The default work directory is in temp Baratine. So we can check the logs. So Baratine is running on port 8085. So let's start with Eclipse to create our very first Baratine microservice. So let's create a new Maven project. Everyone here is using Maven, right?
Yes.
Gradle. So let's name our artifact counter because we want to create counter service. So we need to add the Baratine dependencies. First, we need to add the Baratine repository. Then add the Baratine APIs.
You just made up Caucho for the repository?
Caucho is our company name.
I thought it was Baratine.
That's the name of the product.
That's the name of the product. So group IP is Baratine.io, io.baratine. Artifact is.
So is that a default repository that's out in the server that you can spin up automatically? Or you're going to create a new one?
It's on the internet. It's a Maven repo.
Mm-hmm.
Why didn't you put it in Maven Central?
Baratine is still in beta. Once we go to 1.0 in about 3 months' time, we will put it there.
That's in private user. Right.
So the current version is 0.8.3, and it's just an API is provided. So let's put that in there. So let's create our very first Baratine class, microservice class. And let's name it counter service. In Baratine, in order for a service to be exposed, to be made a service, we need to add an annotation to it, add resource service. And we need to give it a URL where it's going to be located at. And we want to make it public so that it be callable from WebSockets and HTTP clients. And we need to give it a name. So let's just name it counter. That's the name of our service. So what should a counter do? The counter should keep track of the account. So let's add that. Add a few. We should be able to retrieve the account. We should also be able to increment the account. We should also be able to decrement the account. And we probably want to add an arbitrary number to the account. So let's add that. So that's our first microservice. It's only like 10 lines of code. And so let's go ahead and deploy the service to Baratine. Let's compile it first. NVM clean package. So we now have this jar, and we need to deploy it. Everything is done on the command line. So the deploy command is deploy, and then the jar file. So now it's deployed. So we probably want to test it. The easiest way is probably using your browser. The default port is 8085. Our naming convention is S. And then the name of your service, we named it counter here. Then the method that we want to call. So let's call the get method.
Tell it to the port, see whether the port is open.
I'm sorry?
Can we tell it to the port to see whether even the port is open? I mean, you could just quickly tell it and see
so it's listening on this port. Something's going on. Something's wrong right now.
Let's say it's we don't know.
Shut down, I don't think so. I like the command, but
Oh, okay.
This type of command to shut down.
It's the URL. There should be 3 slashes.
I see.
So it's the scheme is public and the name is /counter. So we need to recompile. Right now, there's no redeploy command. We will add it soon. So now you have to shut down and restart. Actually, you have to redeploy, shut down, and start.
Deploy? Has anything?
Yeah, I haven't. Good catch. So we need to shut down.
Yeah, sure.
Start. Okay. So there we go. The count is currently at 0. Baratine returns a JSON representation. If you have a JSON object, if you return an object, JSON will serialize it with JSON. So let's increment the count. We want to call the increment and get, and the count is incrementing.
That's a good question.
yeah,
What happens if 2 increments and gets happen at exactly the same time?
a single thread.
It's single threaded,
So you can't do
so
this.
So then what happens?
there's an ordering. I'll talk about it in more detail. So depends on when which request comes in.
Yeah,
to the
the
service.
request gets serialized. If 2 come, they get serialized because it's a single threaded thing.
whichever HTTP thread gets the control of that service
Mhm.
will get the next one.
Yes, but there's only one thread. I'll talk about that in more detail.
How do you pass in the parameters? You put in parentheses.
So then if it's a long running method, then it just gets blocked.
Yes.
Yeah.
What's the socket there that handles the session control and transport?
This supports HTTPS. It's using HTTP or WebSockets.
The new.
SSL.
No, I mean the lower level, the Java level. Yeah.
It's using our own JNI library.
Oh.
It's using everything internally. There's no dependencies. Everything's built into Baratine within a 7.6 megabyte file. So how do you pass parameters? Not exactly, not right now. So let's increment it by 100. There we go.
We're using Netty, but back in somewhere.
We're using resin internally. Well, yeah. So what happens when we restart the server? Will the count be preserved between restarts? Let's call the get method. So the count is not preserved. Count starts from the beginning again. So in Baratine, we need to tell Baratine to save the service after modifications.
Shouldn't it have been 0?
Because I called the
Increment. The add.
Yeah. So in Baratine, we need to tell it to save it, save the state of the service for us to the internal database. So we do that with an annotation. Everything is done through annotations. So let's recompile. Lower. Shut down. And start back up again. So let's increment the count. The count is currently at 24. Let's shut down Baratine and see what happens. Start back up. So the count stays at 424. The state is persisted across restarts.
So how do you persist?
It's streamed to an internal database automatically. Database is used as a backup copy. It's not used as the critical path. It's not in the critical path. The authoritative copy is this Java field. That's the one in memory. That's the one that your service uses. It's not using some data in the database. It's using that field.
Which means no, your bootstrapping could be taken down. But coming up, when lots of data is in that database, could you think about to come up, correct? To populate all this.
Yes, there's some initial population, but once that's done, everything's in memory.
In the cache.
Yes. So what if you have multiple counters? In Baratine, everything is done by URL. So to be able to have multiple counters, we just need to add an ID field. And the URL, we specify ID. This ID matches with the ID field. So we change ID to 1, 2, 3. We also need to update the URL. And everything's done automatically for you. So let's recompile. Shut down. Right. So So before we had a sequence of one counter servers. So now we should have multiple counters. Now we need to give it the ID for the ID field. So let's give it 111. And we need to give it the method name that we want to call, increment and get. So what if you want to get a different instance of the counter? So 222. And this counter's value counter starts is at 1. It's independent of the other counter. So we go back to 111. Should be counters are independent. They're based on the URL.
So your software matches up that parameter passed in the annotation with the instance variable where it's stored. That ID 123 underscore ID 123.
We use that ID field. It's automatic. We inject the ID into that field. We match
Whenever
it up.
there's braces. Whenever there's braces, you inject it.
Yes.
One question.
We pull it out from the
Is
braces.
it still single threaded for all of these IDs you're going to pass? So it's going to be one thread that manages all these IDs, different IDs? So,
Yes, there's one thread handling all these IDs.
so basically still single.
Still single threaded. So going back to our slides. So this is our counter service. So as you can see, I have some practice. How many lines of code were there?
What does the journal do? Like, I don't think you put that in right there.
Baratine has a journal for extra reliability. It adds some overhead, but not that much. 99% of the cases, you want to have a journal.
What does that feature do?
It journals it after it updates it in memory so that you can recover any crashes.
Yes, it operates like a database, but I'll talk about that in more detail later. So what did we do when we deployed the service to Baratine? Baratine made it callable. Baratine attaches an inbox to it to order incoming requests. Baratine journals the requests for reliability. And the service is streamed to our internal database for backup. And this is what we call Baratine. Everything's within the same JVM. And you get all this in an 8 megabyte distribution. So it seems like there's a lot of magic going on.
So you're saying that these feed off of an internal like queue that contains incoming.
Yes, the inbox is a special type of queue. It's kind of like a ring buffer. It's a ring buffer, but it's very high performance. It allows us to do very special tricks.
It's what kind of a buffer?
A ring buffer.
Ring?
Basically, it just has a limited slots that you kind of override.
You wrap around.
Yeah.
So it seems like there's a lot of magic going on. With only 15 lines of code, there is. There's another type of service, the ad service, that has less magic. It doesn't save for you automatically. There's no automatic restore from restarts. There's no paging. There's no checkpoint. So it's very hardcore, but you get more control. You get control of the journaling. So if you add an add journal annotation, you have control of the journaling. You have control of restoring from restarts. You have control of checkpointing. And you need not concern yourself with this chart. But all you need to get away from this is that Baratine will do a lot of stuff for you. But if you want more control, Baratine allows that. So now I'll pass back to Sean.
Great. And thank you, Nam. So that was our quick start there. So what did we just see? We just saw Nam really go from nuts to bolts of a service that's ready to be deployed to thousands of end users. It's a service that will maintain state among those concurrent users. It's scalable. It's 8 megabytes in file size and has no external dependencies. So what we're going to talk about now is some of the components that we've included inside of Baratine itself and why it's able to really perform the way it performs with no sort of added complexity, no caching layers needed to get the performance benefits out of it, no data grids, no outside dependencies, no queuing layer. It's really the all-in-one solution here. So,
wait, could I add something?
Sure thing.
You just said you demonstrated thousands of concurrent users.
Well, a service.
About single-threaded models.
Right.
Why did you say concurrent?
A single-threaded model that can handle high-load concurrent users.
Okay, now I'm confused. He said that if making the calculation takes a long time, the other one is blocked. If you have, let's say, 3 requests like right next to each other, and let's say each request takes I don't know, 5 seconds, but let's say the requests were a second apart, you're gonna have to wait.
What exactly? I mean, that's a good question. Maybe you elaborate on it. Why do you talk about high scalability if these things are all serialized and kind of requests have to wait in a single? Can you elaborate a little why you call this,
Right,
because it's kind of not very.
Yeah, can you elaborate on the?
Yeah, the
if you have
blocking.
one thread, you cannot call it concurrent. That part.
There's a special way that we manage that within Baratine, so and that's done within the actual components of it. There's a reason why we're able to actually serve concurrent requests on a single thread is because Baratine does a lot of batching. From the inbox, we serve 10 requests over one thread onto what Nam mentioned is the serialized ring buffer, or if you're familiar with LMX's disruptor implementation, it's the same sort of manner. So I think that our slides will answer this as we go on. There's still a lot more to get to in terms of scalability as well, why it scales well.
All right. Well, okay.
Yeah, so just bear with me until.
So based on your wording, it didn't make sense to me.
It doesn't follow a traditional, conventional model of threading anymore. It's these tiny microservices. Well,
Right.
It's not your thread where you're blocking a resource. You don't block it anymore. You're actually continuing to do while something else fills the response to another request.
Right.
So that's the ring buffer magic that Martin Fowler's talked about the disruptor pattern is
Right.
where a lot of this comes from.
Right. And so I think we'll get to your actual specific question a little more in depth. So looking at the components of what we have the key value NoSQL database. We have the journal, JAMP and HAMP. JAMP is JSON over active message protocol, and HAMP is just the binary representation of that hashing. Bartender is similar to Zookeeper. If you guys are familiar with Zookeeper, it's the way that we manage the state of the servers in the cluster, make sure everything's alive and callable. And then we have the web server PDF reports as well. And again, this is 8 megabytes in file size. So
Bartender is something you guys wrote? Or?
Correct. It's our own implementation of what would be comparable to Zookeeper, right? So again, no external dependencies. There was nothing else he installed. Nothing is dependent on. These are the components of it. So when we look at a little bit more in detail how each component is functioning within Baratine, what we're seeing with the inbox is concurrent requests can come into this service, but they're only going to be implemented on it or operated by a single thread. Concurrent requests will come in and fill up the inbox, and at a certain point, the inbox will actually batch the results of that inbox, the request of the inbox, in onto that service itself, which is where you see multiple concurrent requests being handled by a single thread because of that disruptor ring buffer model method, and because that single thread is the only modifier of the data, we can have that with multiple concurrent requests all coming in on that particular service. Looking at our actual communication protocols, as we talked about earlier in the Reactive Manifesto, there's a lot of endpoints of devices, a lot of different use cases and scenarios of devices that will be calling into your service. So we have the basic communication protocols covered here: REST, AJAX, RPC calls. WebSockets, when available, are usually the best, give you the best performance today. And we always have the HTTP long polling for maybe some legacy services or something that a simple GET request that you might want to run there. What's actually demanded?
That's the question. That's good. I mean, generally, okay, you basically can make the thread busy by pushing a batch instead of single threads. But if each item takes a long time to process, still the one on the top of the ring will have to wait a long time to be processed, right? But at the end, it's process serialized. You, of course, increase the throughput of the thread and efficiency of the thread by making this thread doing a batch processing and really process simultaneous requests, not simultaneous, many requests at the same time. But at the end of the day, it's kind of the one at the end of the queue has to wait much longer than the one in the front of the queue.
Well, it's a bit of an architecture design in terms of what's going to be implemented within your own service. So the idea behind microservices is splitting out and abstracting just one component doing one thing well. So if you have tons of requests coming in and modifying one simple service and one actual component, you're not, long-running calculations will always be an issue depending on what you actually want to do. But the idea behind microservices is that you have a service that modifies either one set of data or does one thing, so that you're not inherently calling in and waiting on the traditional multiples. Exactly. So it is a bit of a different in terms of what's demanded by it. So when we're looking at the component of what's required by the actual end user to develop, we saw NOM's implementation was actually a simple, plain old Java object, annotated with the resource service with the URL of where he wanted to locate it at, and he also annotated it with the modify to let us know that we wanted to persist this state in the event of a crash and recover that state. So those are really the components that we've included within Baratine, because as you can see, they're the components that were required for this microservice model. So we had this idea of the data and business logic, and also this reactive manifesto that really demanded a lot. And we really combined that into one real small, efficient model that we call Baratine. A lot of questions that have came up, and rightfully so, have been more about the reactive manifesto. So how do we handle responsiveness? How do we handle scalability? It's been thrown out there, but we haven't gone in depth about it. How is the service resilient, and how is it in the way event-driven? Microservices inherently are event-driven because you have a lot of particular microservices that would each work on a specific component of the overall service that you might be delivering. But let's take a look at how we maintain responsiveness in terms of performance. So when we talk about performance, it's often, at times a buzzword that's thrown out there. A lot of caches, a lot of data grids, a lot of HTTP accelerators will claim performance. But what we're talking about when we say performance in terms of your application and your hardware is mechanical sympathy. So what we have here is Amdahl's law. Amdahl's law really says, I'll read it verbatim, the speed up of your program is using multiple processors and parallel computing is limited by the sequential fraction of your program. So as it shows there, if you have a program that can be 95% parallelized, the portion of it that cannot run in parallelization, the portion of it that has to be serialized, is going to be the limiting factor. That's really what we're seeing here in terms of the actual performance. So when we look at Baratine, Baratine's a little different in that Baratine is single-threaded by nature. So Baratine's able to actually take those services and deliver those services onto a single core. So multi-core CPUs are no longer blocking on an architecture or on a service call where they have to do a lot of CPU context switching. You get better CPU affinity here when you have a service that's modifying its own data on a single thread, and this is the only thread is the only thread in a highly concurrent environment that's going to be modifying its data.
So to use Baratine best, you would want to split your everything that could be parallelized out to separate it.
Right. Well,
separate microprocesses.
Right. Right, in a way. So yeah, microprocessors exactly.
Well,
So
it can't be parallel.
But
right, the portion of your code that's not going to be ran in parallel, we want to make that portion that can be ran in parallel fast as possible. So we put them in a batch call on a single thread and scream through them on the disruptor. The portion of it that's not, that won't be that can be done in parallel. Then we can asynchronously call out to those portions of the service that can be done there. What this means in terms of Baratine's performance, we will actually go into detail and look at the code implementation of how performance is affected within Baratine's model itself.
Let me ask you something. You just throw out the thread affinity, core affinity.
Right.
But the core affinity, even if you don't have any synchronization queue, so that, as you said, basically, you really are not allowed to. But still, you don't get a core affinity. Still, the scheduler on the OS is going to switch from one core to the other to the other. There's no way, unless you really write a C++ code that generates a core affinity to make sure that this guy stays on one core and doesn't get switched. The scheduler tends to switch even those blocks that are really purely clean, like yours,
But
from core to core. So it's not that.
That's always the case. You don't have control over that. What we have control is at the addition level.
That's absolutely right. That's why I said really over core affinity and over context switching, you don't have much control. Even if you write this clean code, you basically really, honestly, unless you really write more C code that you really create an affinity.
Well, presumably, if this thing really takes off, people will write schedulers that have that flexibility.
I mean, you have to write the OS schedule, or basically write C code. You could write a C code that actually creates that core affinity, but you gotta write the C code.
Right, and more importantly there, what we don't want to be doing is when the scheduler switches contexts, we don't want to be in the middle of a blocking call and then have a performance degradation. So when we have this model of the single thread here.
Okay, yeah, it's clean. I agree.
Right. And we will go into a little more detail here. Now I'm just going to cover some actual code examples with Baratine itself and performance.
I can tell that you guys are impatient about the performance details.
We like you.
So let's go over the performance details. So Baratine is a complete microservice platform because it scales, performs. You don't need a caching layer. You don't need a database.
What do you mean by complete?
By that, it performs. You don't need a database. You don't need a caching layer. The performance is inherent in architecture that I'll talk about. And 180 megabytes. So you get ridiculous performance from Baratine.
That's redonkulous.
Redonkulous. You get redonkulous performance from Baratine. And how do we achieve this? We achieve this with fast, single-threaded performance. And something that's unique to Baratine is this concept of automatic batching. You can do 10 things in one go instead of retrieving a request one at a time. It's like going to the supermarket and buying milk and cereal at the same time, instead of going to the supermarket to buy milk, going back home, and then going back to the supermarket to buy a cereal. So the core component of Baratine is this high-performance queue. It serializes incoming messages and orders them. So we have a lot of requests coming in, chaos from the outside world, comes in, and it gets serialized. And the requests are sent as batches to your service. So instead of the service going back to the inbox after every single request, it retrieves a bunch, executes them, and then goes back to the inbox for the next batch. And this batching is possible because there's only one consumer of the inbox, which is the single-threaded service. If you have multiple threaded servers, things don't work because you don't have any ordering. So what you get is very fast, low latency concurrent performance. It's single-threaded, but it's concurrent because for a certain batch, the CPU core is uninterrupted during that batch. Your code is not telling the CPU to block, to wait, to be a context switch, to be put on the context switch queue. So there's no context switching, there's no pausing, and the direct stream is the entire batch. So there's no blocking, no locking. It's very CPU cache friendly for both data and very importantly, instructions, because it's not going back to the inbox to retrieve the next request. It's just executing that batch without stopping. So CPU is spending most of its time in the code that matters the most, your service code, not in your blocking code, not in the operating system context switching code. It is in your service code.
Are these requests basically they're sitting on a root buffer and you're dispatching them in batch to a, I guess, a constructor?
It's our internal. It's our implementation. That's very similar to the disruptor. That's influenced by the disruptor. Very similar concepts. So what we do is we retrieve the index numbers of the batch. So the service will know that it can work from index 0 to 10 without asking the inbox. So that's why it's not locking or blocking. That's why it's not stopping for that batch. So the core component of batch programming is that you can, within a certain batch, you can do a bunch of computations in memory. You don't have to save until at the very end of that batch. And when the batch is done, you write once to a database. You don't execute a request, save to a database, execute another request, and save to a database. You do everything in memory, and when the batch is done, you write once to the database. So,
What if one of the batch jobs fail?
yes. Is it reliable to batch? Is it reliable to operate in memory? No, usually, but if you have a journal backing you up, then you get to operate like a database. So suppose Baratine checkpoints the service after request number 4, and the server goes down. What happens when the server goes back up? Baratine will replay the requests number 5 and 6. So the service will continue where it left off. So
that add-on checkpoint would be on the increment and get, or would be within the batch.
it would be the add.
Internal. It's internal. So it has certain checkpoints.
How do you invoke that?
You don't invoke it. It basically has certain checkpoints, like a database, that has certain checkpoints. If basically anytime, let's say before that checkpoint,
but how do you? Where does that annotation go?
For an add resource service, it's automatic. You don't have control over the checkpointing. But for a regular service, you can annotate your method, and Baratine will call that method, and you can do whatever you want. You can save to disk, you can save to a database, you can do pretty much whatever.
I mean, what if the code has a bug in it that goes off?
Bug in Baratine or bug in your service? Then you will toss an exception, and Baratine will return that exception to a caller. So it's just like programming to a Java method call. There's no special.
There's no rollback though of the batch.
But it's
It's not a
certain
ton of
that
batches, right?
those services locked.
no, there is actually.
It's
Does it throw the batch out?
It's asynchronous. It's like
Close the
Java
batch.
methods.
Does the batch-
Atomicity is that the batch granularity, and there is no reason to have no rollback because in a database usually you push down the uncontrolled, even uncommitted stuff. That's why you have to actually roll back. Here, since it's really going with
Yeah, you haven't written to
batches,
the database yet. So
my point is, it doesn't matter. The journaling does not need a rollback because it doesn't dump the journal data uncontrolled.
right, it hasn't written to the database until after the batch.
Okay, there are two components: the database and the journal. Okay.
So let me explain. So you can save after the batch is done, or you can save on checkpoint. I think with a journal, it's more efficient to save on checkpoints because you can be super lazy, knowing that you have a journal backing you up. You keep everything in memory until you need to save when Baratine tells you to save. So you can be super lazy in that aspect. And this journaling is it journals your method calls. it doesn't generate the data. It generates your method calls. So in your method calls, you can do whatever you want. If your code goes on section, then goes on section, Java section. So what? It will continue the next request in the batch. So this automatic batching is possible because of the ordering by the inbox and the single-threaded nature of a Baratine service. And Baratine gives you some level performance that's very unique to Baratine. The CPU is uninterrupted during the batch. You're not telling Java to block. You're not telling Java to do a context switch. And you get the freedom to operate in memory safely because of the journal. So operating in memory is what we call operational data. It's keeping the data close to where it's being used. It's not in some database. The database doesn't know anything about your data. It's not in some caching layer because you need to speed things up. It's in the Java fields. And that obviously is in memory. So this is for a single server. We talk about how it scales to multiple servers. So if you have one long running computation, you will want to partition your services. So we talk about that in more detail.
Okay, and I'm just going to recap some of the performance details that he went over. Basically multitasking is bad. So there's a recent study out there that said, a lot of people believe they're good at multitasking. Recent studies show that people are actually 40% less productive every time they try to multitask. Same thing goes with the CPU. I don't know if it's a 1-1 ratio in terms of 40%, but every single time you have multiple cores on your CPU, you're blocking, you're keeping them busy, you're losing productivity. The in-memory service, again, high points here, single-threaded by nature, CPU affinity, and batching. So we actually, the same thread that's used to serve the request from the inbox, we have a single ownership, single data ridership. We're using that same thread, doing a couple cool optimization tricks on that actual call, so we have uninterrupted performance. The inbox itself, as we did look at, is responsible for some implicit ordering of all the actual asynchronous messages that it can receive. So part of the problem that comes in terms of asynchronous messaging is how do you order the messages, how do you debug what comes through. With Baratine, you get an implicit ordering of how the method calls were actually relayed and how they were replayed in the service. A comparison of a multi-threaded environment versus the Baratine environment, as Nam said, you're dealing with synchronized code because your data needs to always be in sync with the people that are using it. So you might write something and you might have a request and response, and you flush after that actual response so you can get a write to the database. You come through, you get a synchronized block again, you have a write, you have a flush, you have a synchronized write, and a flush. These are costly every single time you have to flush. With Baratine, we're batching all those write requests onto that single service and flushing at the end. We're getting automatic batching. In terms of performance, what this actually means, when you're dealing with the features of some of the older Java specs, or if you're dealing with callbacks, if you're dealing with something that you're integrating with that's not asynchronous, it's going to be blocking, we can serve about 186,000 requests per second from Baratine. Inside the JVM, when you're using fully asynchronous services within Baratine, 4 million actual requests per second is what we can actually respond to. So great performance, and the performance is possible because of the actual nature of the single-threaded and batching that Baratine does give to you. So the other portion of the React Manifesto that I mentioned earlier, and that has come up, is scalability. So talk a little bit about the performance. Let's look at the scalability. When we talk about scalability, what are we actually scaling? Well, we're scaling these resource services. They're REST-style URL address services. It's an object-oriented model where the data and the methods are combined into one. And these are represented, again, with their actual URLs and an ID behind them. It can be anything from an auction to a shopping cart, the atomic counter that Nam went through himself, or a list or a queue. The resource service is an actual service that manages multiple resources. So here we have, again, each resource is owned by one service, saved to local disk if need be. They are replicated in that. Well, I'll get to that in a little more detail about 2 slides from here. but again, they are partitioned by the actual URL. So when we look at scalability in general, when we talk about scalability, because oftentimes there's a lot of articles, scalability is a bit of a buzzword itself. So we want to look at 3 factors of scalability, those being sharding, replication, and recoverability. Simply put, with sharding and your actual database, your data that you're working with, if you don't shard, you don't scale. There's been some documented cases out there on the internet of people who've migrated to a NoSQL database, such as MongoDB in its early implementation, and they needed to actually give you great document storage until you needed to persist that to disk, until you needed to scale out to sort of hundreds of thousands of servers, and you needed a way of splitting up that data inherently. Architectures, when you're talking about scaling, that involve a lot of data grids, enterprise service buses, managing some of that business logic, and the actual data itself, it gets very complex very fast. Baratine's model is a model that's inherent to scalability, and let's talk a little bit about how we shard. Sharding is done, resources are partitioned by the URL automatically for the at resource based on the service name and ID. So here we have an example of 3 servers, multiple services, so you see this, the URL name and the actual ID of that service, and they are going to be ordered and implicitly actually sharded onto the actual different services by their service ID and their name there. This allows us to really have a model where your data is never going to outgrow the usage of the service itself. Partitioning and sharding is really the way that everybody managed. Well, sharding is the way that scalability is managed in today's terms, because we are dealing with so much data at times. What makes these actual recoverable and redundant? Well, if we take a look at each one of these actual servers, each server actually has 2 hot backups. So in terms of reliability and recoverability, we streamline that inbox and that journal to the backups, so that if ever your server, one of your sharded servers goes down, automatically the backup can take over, and the backup can start serving those requests for you. So it's a very quick to respond system, and we monitor that with Bartender. It's a heartbeat system, as I mentioned earlier, like Zookeeper. Some of the details on what Bartender is actually meant to do and what it does for us. It manages the failover and scaling with symmetrical gossip protocol. So really, it's doing the checking to manage what's needed when you're working at the cloud level. When you're working in a distributed environment, you need some way to communicate to make sure what servers are up and down. We manage the sharding. We manage the actual a backup for that shard so that we can recover from that. And as Nam showed earlier, we have the at checkpoint that we can restore state right to that server and get your service back up and running exactly how it was before in the event of a crash, in the event of an unexpected restart. So really, when we take a look at it, these are the factors of scalability that need to be addressed when you're talking about a service that adheres to the reactive manifesto, that's agile, that's ready for consumption by millions of end user devices, from cell phones to actual laptops to desktops to any sort of Java client that you may have calling into your actual service.
Okay. Sorry, go ahead. So can you spread these across multi-data centers?
You can. So
across the WAN, then, the heartbeat is not tied to closeness proximity limitations? That's correct.
The heartbeat is actually necessary for the cloud configurations, and it's not labeled by proximity. It's a model that's developed with the sort of EC2 Amazon environment, where you can't guarantee that you'll get the same IP address. You can't guarantee that your box that you're working on right now is going to be the same box that serves that answers that request 10 seconds from now. So in terms of what the bartender is managing, if you're familiar with Zookeeper, it does a lot of those things with a couple of optimization tricks.
So it basically takes care of your, like with Cassandra, with your token generation to provide that ID.
That's correct. So
pretty cool, actually.
Yeah, that's the a lot of the thought.
Can you configure any of these things, like the number of backup copies that you have, the redundancy?
The
Yeah, 2 hot backups, you said.
Yeah, the 2 hot backups are the default. Is it configured? I don't believe it's configurable right now.
Not now.
Yeah,
Oh,
it's not configurable right now.
Probably.
Yeah, and in the future, it's something that we can definitely add in if needed. But
Yeah, most people are going with 3, but I just was curious if it was configured.
But honestly, 3 is a good number. Yeah, some systems you can configure them, like in Hadoop or other systems, you configure the K factor. But 3 is a good number, and you know.
Do you use the configuration file in order to spin these things out into a different cluster, or to set the IP that you want for that?
The configuration file, yeah, can be used to whatever setup that you might have. So this configuration right now is on a single server. But if you needed to configure Baratine so that you had multiple microservices, maybe some in-house, people are talking a lot about public, private, and hybrid clouds. It's a model that supports all of the above.
I have one question. You are jumping. How do you partition this? You provide some information how to partition based on this ID. You didn't mention. Okay, you are now going on 3 servers. How did you decide which ID goes into what server?
Which ID goes? So these actual resource names,
Yeah.
sort of in a round-robin fashion, are going to be distributed to however many servers you're using for your Baratine distribution.
So okay, 0, 1, 2, 3, 4, 5.
Correct.
6.
So in this one, we have a set of 10 services, and 3 of them located here, 3 of them located here, 4 of them located here.
It's based on the hash code of a URL.
You're right.
So we have 3 servers that we will mod it by 3 and send it to the correct server.
Oh, so basically you hash it and mark by number of servers.
Cool. And these servers are virtual. We also have physical and virtual.
What happens if you add another server?
Yeah, hash by mod by number of servers. You kind of, if you add another server, I guess you have to rebalance it, because that's.
I mean, you have to rebalance it, right?
So we chart it based on the virtual server. So you can have 8 virtual servers and only 2 physical servers. So the virtual servers doesn't change, but the physical might change. So we would have to rebalance to the physical, but the virtual stays the same. The hashing of the request would bring that request to the same virtual server all the time.
So you take care of the rebalancing, or that's an admin that has to do that?
In the beta version right now, we don't rebalance it yet, but in 1.0 we will.
Right. So we covered this already. So yeah, that's really how we've addressed and managed the items within Baratine and the services that will be inherited Baratine in terms of scalability, and really what the purpose of these factors within Baratine is for the actual reactive manifesto need of what in service today that you're developing is required. It's not the same sort of architecture from 15 years ago that you would use to develop these services. The only portion that we didn't really talk about in detail here is the actual database itself. So let's cover how the database scales. I believe Nam has another segment for us.
You guys want to take a break? Maybe ask questions?
Sure. Okay. One question. What actual use cases are best suited for this architecture, and what in particular are worst suited for this? In other words, which use cases are not suited for microservice architecture?
We have a slide where we'll talk about some related architectures and some companies there, but use cases that are not meant for microservices is really an architectural decision. I mean,
okay, let me just give you one use case.
Okay.
You tell me if this is good. You guys have these microservices that you keep the data in memory, and that's all cool. If I need to have a cross view of all this data, what do you do? If I had to have a cross view of this data, if I have to basically run constantly reports that report about all this data that are existing in this microservice. No.
So we have this internal database. You can query on it.
Okay,
And
now I'm going back to the database from the other way.
So what we do is we send the requests out to all the servers. Then we do a map reduce, and we retrieve all the results back to the caller.
Because you see, if I go with the database, I'm back in the old model, and now my database is my model. So how do you manage to, okay, because you see, these microservices own the data. If they expose the data, I guess they have to expose the data in a readable way, as you said. How do you get the visibility over this data across your microservices?
So it's just Java method calls. If you want to get some fear, call a method. So you want to update, you call your service to update it. You don't.
But hold on, then I have to call like millions of service calls. If I like right now, every piece is owned by a service and is behind the gate. If I have a large data set, that means now I have to make 10 million calls to get the whole set.
Well, Baratine, like I said, Baratine supports the query language. It would do that calls for you. It would spread out all the calls to all the servers for you, and retrieve the results in a MapReduce type of call. So you don't have to do a call to every single server. That's petition.
Because you're saying that you see every call is like behind the gate. Let's say I have this big data set that is really buried into all these microservices, and I need my data back. That means now I have to make all these gets for the calls. Call get, you know.
But you won't handle it.
Correct.
Baratine will do that for you.
Correct.
Or for a current service, you want to retrieve all the currents. You submit a query to Baratine. Baratine will query all the servers and return the results back to you. So this one call, and Baratine will spread it out to you.
Oh, I see. Right. So basically, you have those services that are internal services that are kind of servicing this type of issue. So basically, let's say you want to have all your content, you make one call, give me all my content, and then you get like an array of all the content back.
Yes. So it's just Java method call.
Right. So yeah, you would have a service that could call to all currently. You also have the option of pointing streaming to a normal offline MySQL Postgres database where you can have your normal sort of offline data that you might want to be running analytics on. It's just it's removed from the operational data that it's actually operating on. So there's a well, it's
no, I understand, but the problem is that mining part that actually always is the bottleneck. I thought it's going to be, you know what I mean? Okay, if you push it to your MySQL, then again.
But it serves as a backup. It's not operational. Like it's not using it in real time, and that's the concept.
A built-in memory cache in front of that back-end persistent store. But so when you create that ID in your Java code, is it serializing that to a particular server? A copy of that program?
When you create an ID, if that's an any ID, and Baratine will create for you, or you can tell Baratine to create an ID, and Baratine will pick a server, to servers that request. I'm sure that answers your question.
I'm just wondering, is there a Java? So each of those three servers that you had up in your example cluster, right? When I create that program with the ID in it, and I create the first one, 12 or something. Is I can have a copy in the JVM on that server 1 for 12, and then for 96 is going to be a different instance of the same code running on a different server.
Yes, different instances.
So you're serializing the Java object and sending it across the cluster.
Not exactly. The data stays
doing
with
something equivalent.
the data stays with the service. The service owns that data. No one else is modifying that data except the service. So if you want to update your data in your service, you need to call your service.
It's a underwriter machine.
Yeah, based on the hash of the URL.
Yeah.
So you don't have this local caching concept. Operations are not done on your local machine. They are done on the server within the service. So this is a new concept where this single owner, single thread model that Baratine gives. And when you keep everything in memory, you get to go to the next level in performance. You don't have to wait on the database. The
So
data's
the
there.
inbox is like spread conceptually across all 3 servers. Is that what I'm trying to get at?
Each service has an inbox. So you have a camera service, a shopping cart service on one machine. You have 2 inboxes, and you partition them across.
Like, how do you know where to go? Like in Cassandra, you have a coordinator, so you go to a coordinator, and it figures out where the data is at.
You can hit any of the servers, and Baratine will relay it to the corporate service. Same concept, same model.
So you say you have a slide of similar technologies, because I noticed in-memory database seems to be kind of a trend.
But it's different.
But this is different.
It's in memory because it's there for each service. It's right there. It's not on different servers.
Right, but I mean, I've seen object databases that are in memory.
Right. To really get that, the quickest way that people have found to get the performance benefit from the bottleneck disk databases to move that into memory, and that's exactly what you're saying. NoSQL databases are being utilized for that. The difference is that it's still splitting your business logic from the actual data, so it's not a merging of the service that's going to be modifying that data. It's really just taking a database and putting it in memory. Whereas Baratine is a merging of the service's business logic on the data being modified.
So, are you guys ready for the next section?
Sure. You never know. It's a lot of back-end data. Doing it. Vacations, yeah, OTAs. I can get data from hotels and jobs. They're going to essentially anywhere with this. Pretty interesting stuff.
So, Baratine's model is much simpler than other architectures. You don't have a separate server for your logic. You don't have a separate server for your database. You don't have to map schemas. You don't have to do other stuff with Baratine. Your schema is your Java class. That's it. It's very easy to start up, to debug the program. It's just your Java class. So let's talk about the database in detail. So the core of Baratine is this big data SQL database. It's a journal, just like a Baratine service. It's actually a Baratine service, so you can see the possibilities of Baratine. You create a very fast distributed database in Baratine. It's supposed to SQL, but there's no joins because the data is partitioned, just like Google's big table. And you get this with Baratine, which is only 8 megabytes. So the database is append only. That's why writes are so fast. All writes, including updates, are written to the end of the block. You're not scanning through the blocks to make it right. You're always writing to the end. Reads will have to scan through the blocks to find the version that's the most current. And the most current version will start at the end. So what you get is very fast writes, very fast reads, because of an in-memory B tree. Usually with big table-like implementations, the reads are slow because there's no B tree. But we have an in-memory B tree to speed things up. And hits and misses have the same cost. if you compare to Google's big table, misses can be very expensive. But with a B tree, the hits and misses are just as fast.
And only so it's immutable? It's immutable records?
Yes, it's append only, so you never override your data. You always write to the very end.
I have a problem to imagine like you have this data really sitting in this microservices, and then let's say you have a mining question that you want to really slice the data in 10 different dimensions. How does that work, and how these type of questions that really are data-driven questions are going to be answered?
Well, Baratine's database supports SQL. So you can write SQL queries.
No, if you go against the database, of course, you're in the old traditional one. Okay, now I'm going against the database.
No, it's like how you get data back. You can call the service, or you can write SQL to retrieve the data.
You write SQL against the database, correct? Against your database backend?
Against your services.
Who's going to parse the SQL? A database engine, or is going to be your microservices? Who's going to parse the SQL?
It's the service. So the service has a duet handling SQL.
Did the service parse?
So everything is within the same JVM, right? There's no separate database server.
Because this database is of course outside your microservice. It's because it's persisting to files, it's persistent. So this database is something you provide, but really does not exist within that VM. It's basically an external entity.
Oh, it's within the same JVM. You can have a database within the same JVM.
No,
You're going against the cache version.
No,
Yes,
but the database is one for all these services. So it cannot be just inside. You understand? So you have some physical location that will persist, correct?
Yes.
It's not cannot be only in memory. Is it only in memory?
The service owns that piece of the database. So it
It's
owns,
sharded, so
Well,
you're
I
only
know
getting
the
that
server maps to that whole piece of database.
it owns it. It's just not massive. It owns that database. The database is not a first-class citizen. It's part of the service.
Oh, so basically the database really is a virtual name for collection of all this microdata, or I don't get it. I'm confused.
Each shard has its own persistent. Each shard has its own server has its own persistent.
No, it says it's in memory. Is it in memory or on disk?
Okay, I tell you. So the first class data is in memory.
Okay, that's okay.
It's back up to database. The database is just the backup.
I know, but that database is not in memory. That database writes into the disk.
Yes.
Okay.
Yes. So you keep everything in memory. The database is just a backup site. If you crash, you can restore. Or
I know the database is a backup for Bootstrap. I understand this, but this database exists as an external entity, correct?
it's internal to that service. It belongs to that service.
If you consider just an external entity, then only the application
Is internal to
can access
that.
it.
So you need to save it somewhere, right? You need to save to disk, and we just happen to save to database that saves to the disk, right?
That's correct. That's why. So basically, you have, let's say, 10 services. When they persist, they all talk to the one database that.
No, each service owns its own shard of a database.
Correct. Its own sharding of the database, but at the end, it's one shard of the database, correct?
And all the writes and reads it needs to do, it goes to that shard only. It doesn't have to go to a different server.
But that's why you could write queries that go across this sharding, correct? Otherwise, there is no connection. There is no way you could query cross shard.
So Baratine has a query language that will send requests to all the servers, to all the shards, and pulls the results back to you.
Map reduce.
Like my
Map reduce.
Right. Right. Oh, it's like MapReduce.
Yeah, like
Yes.
map reduce.
Does it expose
Do you have some kind of
MapReduce?
compaction?
Yes.
Do you have some kind of compaction for your immutable data?
What do you mean?
The way Cassandra does? to speed up the reads or to compact? Because you're having to scan every time to figure out what the actual data is from your updates.
I'm not sure I understand.
Okay,
Can you?
just take it off.
How do you know that data is actually there without scanning?
We have a B tree. The B tree will tell us like it's a coarse grained B tree. It doesn't tell us exactly if it's there or not. It will tell us it will be in this block. So you have to read one block at most. You don't have to read scan through like 10 blocks like Google's big table. So the key point is that the database is partitioned, same as services. Service data, the one that's in memory, and the database resides on the same JVM. They don't leave the JVM. So Baratine service never has to leave the JVM for its own data. That's Baratine's model. You don't have to go to a separate server. It's there already for you to use. You don't have to block. You don't have to wait for anyone. You own your data. The service has an authoritative copy in memory already, which is your POJO class. It's used in your Java class. It's not in some database. You don't have to wait for a database. And it's backed up to a database. The database serves as a backup. It's not on the critical path anymore. So this is what we call operational data, where the data is where you need it to be, instead of having to make calls to get the data in.
But I still have a really hard time to do this. Okay, how do you basically run MapReduce jobs? Okay, I mean, it's very close to MapReduce, but then can you really write SQL, ANSYS SQL that goes to these microspaces, and who wrote that SQL engine? Who wrote that?
We wrote it.
You wrote a SQL engine that goes, and how
Yes.
much SQL are you supporting? What's the
Right now, the support is very limited, but we can support any SQL query, except Jorns, of course.
Okay.
So you write SQL,
So
and
you have some limited SQL that you support, like you basically Cassandra support. SQL, okay, you guys have your own SQL, and I got it.
It's very simple because if you're talking no joins, I mean,
Exactly.
it's very simple.
Yeah, that's very simple.
Well, it doesn't
basically,
need to really do joins. All it needs to do is ship the query off. At worst case, it ships the query off to every server in the cluster, and then combines everything with MapReduce. So it's like a CETA, so like a staged event-driven architecture.
So basically, you have this.
Because you have all those separate threads on each server working in parallel. And you
Yes.
combine it.
this is how you get concurrency in Baratine. You have a thread on the inbox, you have a thread on the service, you have a thread on your database, and you are able to use multi-cores that way.
Right.
And if a single thread for your service is not enough, then you partition it across multiple servers. So if you have a long running operation, then you would partition it.
But okay, like for example, this partition you created, okay? The partitioning goes based on different counters round robin. If I have a question that which of these counters are 2, there is no way you could really limit. You have to now go to every node and look into which counters are 2.
For now, we might add a bloom filter to speed things up.
That's what that was.
So basically, I'm just saying, generally, basically, it might be.
That would sacrifice space if you have a bloom filter, but it would cut down the number of nodes that you have to search. Right?
Yeah.
Cassandra does something similar.
So instead of sending queries to 16 servers, all 16 servers, the bloom filter might require only like 4 queries to 4 servers only. Queries to 4 servers only.
And one of them might not be necessary, but you'll be guaranteed to get a result.
Well,
You know, it doesn't.
how is it the Bloom filter helping here? I'm asking which counter is 2. How can the Bloom filter help here? Can someone tell me that?
So it's based on the
The
URL.
probability of the data being found in a particular node.
What do you mean the probability of the data being found? I'm talking about the counters. Which one of those are
Okay.
2?
If,
Number 2. I mean, there is no filter that helps here.
so you have to do a query on the server, which
On all the
count is
servers.
0.
Exactly.
Yeah, you,
So or a certain value you have at this point to go to each of those microservices.
right now we kind of kind of like index on the ID only. You can index on any Java field, but we don't do it now.
Yeah, that's exactly that's one thing I said. Okay, you guys have looks like a limited mining capability compared to Redshift or compared to at least column database, because now there are a series of questions that really you have to brute force the data in order to get your answer.
Mm-hmm. But it's asynchronous, so you don't have to wait.
Correct.
And it's in memory, so it's very fast.
That's correct too.
So this performance is on a different.
It's like a MapReduce that's brute force, and yeah, but it's maybe better than MapReduce because the data is in memory.
So everything is within the same JVM. The data is in memory. So this is what we call an impedance match, not a mismatch. You don't have to hit separate servers. And this is the beauty of Baratine. Everything is there for you, there for your service to use, to modify, to update. And Baratine is only 8 megabytes.
Wait, is it only 8 megabytes?
Only 8 megabytes. Just
Okay, just don't get that clear.
Why do you keep on stressing that?
Yeah.
So we're thinking, yeah, that costs 10 cents or something.
Because
You said it was only 80 megabytes. Yeah, okay. That's good.
because he was concerned about our database. Are we using some external database? No, we're not. We build it ourselves.
So basically, it's kind of this distributed database that probably really caches the stuff into the local disk.
Since they want to put in our credit cards, that's why.
Because at the end, this database persists to disk, correct? Am I right?
Yes.
So basically, if you have, let's say, on the server, let's say 50 services running, so they're going to be talking to the disk because they're going to have to persist to the disk at the end of the day.
Mm-hmm. But it's append only, so
Yeah,
it's
it's
very
append
fast.
only, it's fast, of course. It's just use at bootstrap time, whatever. Yeah, that's correct.
So since Baratine is only 8 megabytes, it's embeddable. You just need 3 lines to bootstrap Baratine to your service. Baratine will attach an inbox, journal database, and you can call your service just like any Java method calls. And they mentioned that Baratine is only 8 megabytes.
So when
No,
you're
I don't
embedded,
remember. How
let's say
big
you just
was
have
it?
some.
How big was it in turn?
It's 8 megabytes.
How big was it when you
Sorry.
started writing this thing?
It's around 6 megabytes.
It was 6 megabytes.
I mean, actually, it was 20 megabytes.
Did you have a cut down version of it? Or what?
Well, wait a minute. So when you run Baratine, you have to communicate to the HTTP, right? HTTP.
You can use Java clients, you can use WebSockets or HTTP.
When it's embedded,
They're more lightweight protocol too.
when it's embedded, is it
Java. Hessian. We use Hessian.
Hessian?
Yes.
Okay.
It's like a fully cloud buffers.
Does it still have to go across the layer and embedded?
Protocol buffers?
Wait,
Tom,
that's
you're right
hold
here.
on, quiet, shut up.
Yeah.
I didn't answer my question.
What was your question? I kind of got distracted.
Yeah, so stop distracting. So the question is, if you're embedding it, and let's say the embedded system is a client, does it still have to go across the layer?
No, it's goes directly to the inbox.
That's my question.
So I'll pass it back to Sean.
So you're not supporting a Spring though, going 8 megabyte, I guess you're not supporting a Spring. I'm just kidding. Okay.
Don't get that look.
We-
Look at that look at
Well, I got this. We support CDI, so you can use CDI.
Okay, great. So, what we've really presented, what we've talked about so far, is the microservice model that Baratine does present. And I guess the one thing that we didn't really touch on yet is who's using microservices, why is it relevant? Oh, there are some inherent.
It's our internal CDI implementation. It's not using RHEL. It's our own.
Right, Indy, for shortcut. So who's using microservices? What are some similar sort of architectures that you might find that people are achieving these with? Was a question that came up, and let's take a look at some of those right now. So related architectures, we're really saying that some of these specs that really were developed about 10 to 15 years ago are inherently blocking by nature, are inherently were never designed for multi-core CPU. So of course you can integrate with Java EE. You're not going to get that fully asynchronous. You're going to be usually returning something to a queue, and that's really just a normal blocking method there. When we're talking about related architecture in terms of the benefits that Baratine might provide, you might see something like an enterprise service bus combined with a data grid, a cache, a NoSQL database, and an asynchronous API in front of it. The point of microservices is to give a bounded context to a service that's simple, that's elegant, that's easily understandable by everybody. And when you're adding that many components to your actual architecture, are you getting something that's simpler to debug? Are you getting something that's less complex? You might get the benefits because you do have the inherent in-memory models that these architectures do provide. But what does that architecture end up looking like? This would be an architecture that some people would consider for building a microservice. They would consider it advanced. We have Node.js at the front here. Receiving all of our asynchronously receiving all of our responses. We have Redis for the messaging queuing and data caching here. A data layer and a persistent offline storage sort of model. When we think back to the actual WAR file and the depiction of the servlets in the front end and back end being the database there, if you're trying to architect a microservice by throwing in something that requires your developers to know another programming language, JavaScript, it's not necessarily bad. It's just, will that microservice give you benefit the organization of the reactive manifesto? Is it an architecture that's going to allow your developers to quickly understand, and quickly scale out? And that's why Baratine is so simple in its model. That's why Baratine does bring a lot of great benefits, because its only requirement of you is that you write plain old Java objects. We're talking about integration in terms of where you can take Baratine today. Embedding Baratine, as Nam covered, 4 simple lines that will give your services give your data services the ability to be accessed concurrently across from multiple endpoints and multiple devices. You can use Baratine as a service gateway to maybe an older Hibernate, JDBC, Postgres database that you have offline there, or you can take the route that a lot of the forerunners of microservices have taken. So Steve Yege had a rant. He's a guy who used to work at Amazon and Google, and back in 2006 he had a rant where he talked about working at Amazon was something he did not like, but one great thing that did come out of it was the fact that they re-architected for microservices. So one of the actual commands that came down from the CEO at Amazon was that they were now going to re-architect all of their services and internally have their applications communicate the same way they're going to communicate to end users. While the inherent benefits were not easily perceivable from the start, there's a lot of great benefits that you get from this sort of architecture. The first sort of benefit that you can get on a Baratine architecture is the fact that you have a data and service molded together. So it's an idea you have to wrap your head around that does not follow the traditional model of data and then business logic. It's really a meshing of the two. What's defined within that bounded context for that microservice. You get a simple architecture, you get increased collaboration. So when you have a set of microservices, for example, Amazon uses about 160 cores to pull down one page for you. Is that overkill? Well, not necessarily. There's a new concept of data gravity that's really out there that talks about the fact that when you can expose endpoints of your data on a massive scale to end users, people will gravitate and start using that data and using it, maybe asking you for ways that was never really designed for. The internet was not ever designed with the particular use case of building a company like Facebook, like Amazon, like Google. What the internet was, though, was a great platform for people to build on top of and allowed them to really allow the platform to evolve to what it is today. Microservices really gives you that promise of building on a platform that can be continuously integrated. Amazon, Netflix, they're rolling out 2 to 3 releases a day that you might not even notice because it is so smooth in their transitions. There's ownership of the code when you have a team that's responsible for a microservice. It's no longer that they write their code and they throw it into QA or throw it into production and it's done. Your code is done when it's removed from production, but because you are responsible for that code, you actually get better and well-written, resilient code. It's analogous to the analogy would be driving a car down the street. If we had if instead of airbags we had a 6-inch steel blade sticking right behind us, we're going to get less car accidents because people are going to drive a lot safer, right? So the idea behind microservices is if people are now responsible for their code from the development to the deployment of it, and while it's in deployment as well, they will write better, more resilient, more code that adheres to the principles because they're going to be responsible for debugging that code. So you have microservices. It's a question of how many developers does it take to change a light bulb? Well, maybe 1, maybe 2 at most, but at 3 or 4, you inherently begin stepping on each other's feet. Who broke the build? Maybe one person wants to change the customer object. Microservices allows you to modify your application in a state where you can continually give you this positive influence and integration. The sort of services, this is from Adrian Profit, I believe is his name, at Netflix, mentioned that when they did re-architected this, that Netflix was a company that went from just delivering CDs, right? People would interact with their site just to get their addresses right, to people that would be constantly on their site with streaming data. They were only able to manage that because they moved to an agile microservice architecture. They were forced to go this direction. But now you see Netflix is really one of the leaders in the space in terms of the inherent benefits that they've gotten by architecting towards a microservice application. Their cost and the size of their risk has changed. So we talked about the monolith earlier, and that people have this real fear they don't want to go in there and change things. Maybe the developers who initially described it aren't there. Maybe you're bringing aboard junior level engineers that don't understand all the components of your architecture and your code. With the microservice architecture and Baratine in particular, you're not asking much for a developer to come on and be able to write asynchronous, non-blocking, distributed, scalable code and easily start contributing to the actual implementation of your architecture. So the innovation cycle looks like act, observe, orient, and decide. With a lot of the big data coming off of the orient, a lot of the decisions there, you're sharing plans, and really a cycle that gives you that continuous integration of what the reactive manifesto demands and needs in today's society. So big picture here, when we take a look just the high level view, what microservices are. Microservices are really the new way people are doing development. There's a couple companies that are ahead of the curve already. Amazon being one of those. Amazon's a company that was able to build their cloud platform because back in 2005 when they started changing over to microservices, well, now they have a lot of these data centers. They have these the ability to look at services being used, to look at the data being used, to provide a platform that everybody else now gravitates to because their platform is microservice by nature.
Actually, I was at a conference 2-3 months ago, and Amazon was talking about this. Amazon executive was talking about this continuous delivery into production, and he never mentioned the fourth microservice, which actually, he always bragged about how they get to this continuous integration to this different complex piping they had. Actually, they really once the code is injected into the source control, how it moves from one stage to the other. But this really simplifies a lot in microservices, of course, and they didn't even mention it.
Right. So yeah, exactly. It's inherent to their culture because they've actually been doing it for 8 years now. So it's something that they're used to doing. Whereas a lot of the industry, a lot of people are still architecting on let's speed up performance by adding a caching or a data grid in, and let's bring those as the diagram showed. The idea should be that you're able to get a less complex, better performing system on microservices. Netflix does have the benefit of having senior engineers aboard. I've heard that they only hire senior engineers, and that's because for them to have their microservice architecture, it's a very complex architecture. Baratine gives you the ability to start building these microservice architectures in a very simple manner that you can start integrating them and getting the benefits out of what they should actually be. So one other quick example was Guilt is a company who does a lot of flash sales, and they went from one monolithic application to over 350 services. If you check out infoq.com, there's an interview with one of their lead infrastructure engineers, and he just talks about some of the benefits that they've gotten from having 350 microservices versus their one monolithic application. So what's next for us? Baratine.io is a site that we keep maintaining. We also have the Google groups. If you search Baratine, you'll see the new releases. As Nam mentioned, we are beta, but we're beta because really 3 months down the line here, we're looking at a production release cycle, and we've had 16 years in the industry in terms of what Caucho, what we've learned, where we've seen the industry progress, what we see needed, and what we see wanted by end users in development is a platform to build microservices on. And today it's just too difficult, too much plumbing code to get the actual end result of what a microservices promises. And that's why we've released an open source Baratine. Last thing to mention here is that we have given this talk once before, and we're having an operational data training session. We're holding one in October, one in November. I do have a couple spots actually left still. The spots are filling up because Baratine is a different model.
Get one.
Speak with Alex, and she can definitely get you guys signed up.
Where are you guys out of?
It'll be in San Diego at our offices.
That's where you're out of?
Yeah, we're located. We have a couple different offices, but the office that we're holding the training session will be down in sunny San Diego.
During the week or a weekend?
Right now it's scheduled for a weekday.
What weekend?
It's on a Friday and a Monday.
Monday.
So, yeah, both sort of crowds there, that's why we had to cater to both. And with that, we conclude our Baratine production.
How do you guys make money?
So it's the new model. No GPL models out there. MongoDB, support services and training is really where you get companies that will use your software and get enough benefit out of your software that they will pay for a support contract. Whether or not they use it, obviously we hope you do, pays for the support contract. But it's really the new model of Nginx, for example. This new software industry model, because and it's partly related to the early 2000 implementation of SOA that locked a lot of people into an architecture that was closed source, that they spent more money on a closed source solution than an open source one. So our model
is really cool project.
Great. So this time we'll take any questions that you guys might have.
So basically, guys, if you compare this with other distributed frameworks out there, like Hadoop or Storm, Spark, how do you see the contrast? What are the key differences? What are the key actually similarities here?
Right. So the main difference that we present here with Baratine is the idea of data with your business logic being contained within the bounded context of that microservice. Platforms like Vertex, like Node.js, like Hadoop is really, Hadoop has tons and tons of actual use cases, but all the people are doing sort of an analysis on their data. Baratine's inherent structure, the way it's scaled, does support that Hadoop sort of MapReduce nature, as Nam spoke about earlier. But the reason why Baratine, holds such great importance to us, and why we see huge potential uptake in the Java community, is that it gives you benefits to your architecture while reducing the complexity. So that's really that's really the key model there, is that you don't want to add in extra components. You don't want to have to deal with database schema migration. You don't want to have to deal with your cache getting out of sync. You don't want to deal with throwing in a new language just so that your developers can get the benefit of asynchronous requests. It's a model that moves towards object-oriented by having data. I mean, the original complaint of JEE was that it was supposed to be an object-oriented model, but it ended up pulling you away from that object-oriented, and you ended up writing all these XML annotations that really was not necessary. So we're looking at that. We're looking at what's required, needed in terms of a service, what needs to be, what the Reactor Manifesto is demanding of today's applications, and a way to simplify that, and that's what we've created with Baratine.
But there would be no way to do it, have transaction boundaries on this.
So transactions, in particular distributed transactions in the sort of microservice world, is a bit of an anti-pattern. You can have transactions in the sense of if something needs to be ACID, you can always have a callback that goes back to the queue, and the queue waits for that result to be delivered. But the idea being that you shouldn't architect your microservices in a way that they are inherently blocking and waiting on response calls to go forward. Some situations it's going to be unavoidable, but when you have data services and microservices in general that are communicating with the outside world the same way they communicate inside, you get a lot of inherent benefits that we talked about.
Is there like a way to put cap over this thing?
No, but honestly,
like, consistency wise, availability wise, is there a way to say your microservice architecture is going to provide measurements of consistency across some such domain of microservices, say matrix mutations, they provide new name configurations or.
Since the service owns the data,
the service does own the data.
The transaction up
100%.
100%. You want to have a transaction, put everything in one service, right?
Okay. Yeah.
But if you can't, you probably use MySQL. But in the future, we might have a transaction manager. But it will be hitting one server, and you have to bottleneck off that one server.
So, but again, as long as everything is in one service, I think forget about the distributed transaction, which are the complex topic, but usual transactions, since you journal this inbox, you have a guarantee that actually you never lose any data. So
right.
Even as long as you really are atomic within one service, so basically everything is bounded to one service, you don't need even to wait, because you really are guaranteed that you're not going to be losing it. It's nothing going to happen, because basically you are journaling this info.
So you don't consider it as volatile.
See, what I'm thinking is transactions going through and the system crashes.
But that's guaranteed.
But your journal may be halfway, the transaction
and then that gets
halfway
repeated.
done.
That gets repeated. That's the whole point of the journal.
But I'm saying, well,
you say through the journal, if you are crashing in the middle of a checkpoint, okay, that whole batch gets repeated.
The short answer would be there's no partition tolerance for it. It's not partition. So it would be just a regular like a SQL, CA. Right? There's no partition tolerance built into it. That's what you sacrifice. Right? And so it's more like a traditional database. It's more recoverable that way.
Right.
Except there's no full transactional guarantee.
Right, and the way to really think about transactions and when you're dealing with microservices is around item potency. So you have 3, 4, or 5 things that need to complete to finish your transaction. You want to be able to, if 3 can go through and 2 of them fail, rerun that with the next time they run, it doesn't create anything new. It just says these have already ran. Here's a result again. So there's
you have to be out-of-potent. Otherwise, yes, you have to be out-of-potent. Otherwise, the part of the batch, let's say you basically are crashing in the middle of the batch. The one that is committed is going to create actually inconsistency if it runs again.
Right.
Unless you're out-of-potent. If you're out-of-potent, then it's going to be.
So you're saying that it's durable. So basically, it's a durable data store.
Yeah, indeed.
Yes.
Yes, it's durable. And it sounds durable. It sounds durable, doesn't it? I think it's durable.
You get to operate like a database, so durable transactions.
These operators of the database.
We just want to avoid some of the same buzzwords that have been used to describe in the past, so we're not calling it that. But hopefully by showing the underlying inner workings of it, the durability of how Baratine performs is then routine for us. And these are great questions and the reason why we're having the training session.
Yeah. So I guess you have full consistency, and the only thing you're lacking really is rollback capability. So you just have to make sure that within building your application, that if you have to have 5 items, then that you check your, I guess, your return codes.
No, that's why you said
For an exception.
Actually,
There's
Any more?
a couple different ways to handle rollbacks. One would be to look at the actual serialized request that came in on that inbox, and then on the application side, or separate from the microservice itself, you want to handle the callback of what happens if you get a normal exception, or if you get something that needs to be decommitted. But really, when people are usually talking about rollbacks, it's in the sense of a normal MySQL database and a normal ACID transaction. But when you architect truly microservice components, the rollback of that data is something that's managed a little bit outside of the actual service itself. So there's a couple ways to handle that, and some of those patterns we'll cover in the training session. Did you have something to add?
Oh, and since the database is append only, there could be multiple versions of your data. So we could add support for rollbacks on database level by rolling back the blocks and getting the fast version.
Cool.
What's that?
which actually I guess you do it in your service. If I write the microservice, I basically have to write it in an artifact fashion, which means I have to really have an identifier for a worker ID that comes in. If I see that identifier again, I know I crashed. And basically, at that point, I basically have to make sure I don't produce some inconsistency by ignoring something that is already processed.
Correct.
So Baratine has these annotations that it will call, life cycle annotations. It will call when the journal is in play. It will call you when the batch is done. It will call you when your service is starting up. And it will call you when your service is finished with the journal, ready to serve normal requests. So you can hook into those life cycle methods, annotations, to handle or backup, restore, crashing, and whatnot.
It sounds like a real possibility.
So, is there anything out there similar to what you have?
Is there anything similar? Let me ask you that.
Spring Boot?
Yeah, honestly, it's so different.
Well, I mean, obviously, you see like in-memory object databases that log to a SQL server or something like that. Similar, but then you don't have the actual class.
It's interesting, because really you cannot compare it even with the memory database, because here the logic and data kind of really together.
And it's not saying that it's meant to replace your entire database. It's just that your database can now be used for the sort of offline analytic stuff. You move your operational data outside of that database, and you can still have a MySQL database that you might do some sort of big data analysis on. It's just no longer the operational path of your service.
That's correct, but again, the issues are always related to that mining. If somebody builds a system today, they're really looking to get this mining fast, and the traditional ones like MySQL doing the mining, you don't go anywhere. Right? Am I right? I mean, have you seen a MySQL mining that has this?
So the MySQL is just an example.
I'm just telling you, if you better do the mining on this distributed fashion, otherwise, that's the whole point. That mining question comes in, you don't have to go to MySQL to do the other methods of mining. You really do the mining in a distributed fashion. Otherwise, you're back to the where you built 40 years ago.
Yes, that's very ambitious. We are not there yet. We
You're
want to
not
be
there yet. Yeah.
We want to be there eventually. After 1.0.
Do you have authentication for authorization for your microservice?
Um,
The rest.
No, not at this moment. But we have this concept of a session that will be in 1.0. That would be similar to sessions. You can log in.
Thank you. Thanks for the great
So did
questions.
you really write the whole thing from scratch? You're saying there's no outside dependencies. Did you at least get code from somewhere else and put it in there? I'm just curious. Because 8 megabytes is huge though if you write it yourself, right?
So Caucho is behind Resin, the Java application server. We are Java EE6 certified, so we have CDI, we have all this stuff, JASP. We moved those components into Baratine, and we added a bunch more. So everything's built in-house. So
Right, and it's Baratine, really is a culmination of that past 16 years, and Resin actually was the first Java EE certified web profile certified application server, because there was components of the Java EE profile that from the start really our lead engineer did not believe that majority of developers out there today did not need to use, and that's why we pushed for the actual web profile, Java EE web profile. From that that was actually back in 2006, so flash forward 8 years, and we're at this point where the promise of in-memory, the promise of thank you. Thank you. The promise of in-memory, as well as what's really required and what we can do, pulling from our past experiences, has allowed us to pull that together into Baratine.
Do you have a testing framework? We're going to write unit test.
we support JUnit, and since it's embeddable, we can
Be able to mock out stuff.
mock out stuff. Yes.
Thank you, everybody, for the great questions and feedback too.
Thank you for coming down from San Diego. Oh my gosh.
Thanks for the hard questions.
You're welcome.
I have
Very
questions.
interesting, actually. Very different. Very different. From what you see out there.
I was sweating every time you asked a question.
So let me end the meeting here, actually.
Do you have any
Let's
points
hit the-
left on the
Yes.
Actually, you can screen share.
Oh, you can contact me. I'll send
Thanks.
you information.
So hang on.
Yeah. Okay, everybody, thank you for attending the LAJUG, and
Mario.
we'll see you next month.
Baratine training.